So last class we did a revision of some gas laws which we already have done in class 9 last year. Then some of the new laws which we have to do in class 10. So one of the law that last time we discussed is Gay-Lussac's law of combining volumes. So what does it say? It states that whenever gases react, they do so in volumes. Whenever gases react, they do so in volumes that bears a simple whole number ratio. Between the reacting volumes of gases and to the product of gas and to the gaseous products. That means they will have simple whole number ratio between the reactants as well as with the products, provided they are measured in same temperature and pressure. Provided the volume of gases is measured at same temperature and pressure. So there must be similar conditions of temperature and pressure. If that is there, then the gases react in volumes which bears simple whole number ratio to one another and to the volumes of the product. So that is there. Now, one very much important thing regarding Gay-Lussac's law is Gay-Lussac's law is valid only for gases. Gay-Lussac's law is valid only for gases. That means the volumes of solids and liquids are considered to be zero. The volumes of gases and liquids are considered to be zero. So whenever you are doing numericals related to Gay-Lussac's law, then what you have to consider? You have to consider that volume of solid and liquid, whatever, either it is reactant or product, it is considered to be zero. That means this is applicable to the gases only. Okay. And last time only I said you this simple whole number ratio means whenever these gases are combining, they do so in simple whole number ratio, means they do not combine in fractions. So this is also called stoichiometry. Okay, so they do so in a simple whole number ratio. Now I'll be explaining this Gay-Lussac's law with this example. Numericals based on Gay-Lussac's law. There are few numericals in your book. I'll be doing this. So following this you can do rest. Let's see. What is the question? What volume of oxygen would be required to burn completely 200 ml of acetylene? What is the formula for acetylene? C2H2. And what would be the volume of carbon dioxide formed? So they are writing chemical reaction in sentence. You have to write this chemical reaction in chemical equation, in the form of chemical equation. Okay, then you will be proceeding. So first of all, you have to convert this sentence reaction in the form of sentence into chemical equation. So what volume of oxygen would be required to burn? That means for burning what we are using? Oxygen. One thing is oxygen, one reactant is oxygen and another reactant is acetylene. And what is the product we are getting? Carbon dioxide. And mind you one thing, whenever hydrocarbon burns, hydrocarbon means compound containing hydrogen and carbon only. This is hydrocarbon. CO2 is not hydrocarbon because it is compound of carbon and oxygen. Compound of carbon and hydrogen only are called hydrocarbons. So whenever hydrocarbons burns, they give carbon dioxide and water. Water. Yeah. So let me write chemical equation. Acetylene, what is the formula? C2H2 plus. It is reacting with oxygen, and it gives carbon dioxide plus water. It gives carbon dioxide plus water. So what is not mentioned here, you should know, whenever hydrocarbon burns, it gives carbon dioxide and water plus heat and light. Okay, now this is chemical equation. And check the number of atoms on both the sides, carbon 2, carbon 1. That means it is unbalanced, it is not balanced. So balance this chemical equation. On balancing, what do you get? On balancing, here C2, here C1. So if you write here also 2, then C2, okay. Now go for hydrogen 2 and hydrogen 2, okay. Oxygen 2 and here 2 2s are 4 and 1 5. It is not balanced. Oxygen is not balanced. Yes. So how will you do then? How will you do? This side oxygen is 2 2s are 4 and 1 5, and this side oxygen is 2 only. How will you balance this? So how can you do? A simple way is there. What you can do is this side is 5 and this side is 2 only. So if you write this, then also you will get right, because this side is also 5, 2 and 2 cancels. But I think you will get confused with this. So what you will do is you will just change this only. That is the trick actually, if you can follow. See, this side you are getting 5 and this side if you write 5 by 2, that 5 by 2 is 2.5. 2.5 into 2 is 5 only, so balanced. But since we cannot write in fraction, so how can we omit this 2? Multiply whole by 2. Then this can be omitted. So if you write 2 here, if you write 2 here, then this gets cancelled. If you write 2 here, yes? Oh, already it was 2 and 2 into 2, 4 and here 2. Then it will be balanced. Otherwise you can try your method, because these are all heat and trial method. I say you the easiest way. Whenever you are balancing this one, chemical equation with hydrocarbons, then your priority must be with this one, carbon. First of all, balance carbon, and then these fractions you can cancel. So what we are getting on balancing? What we are getting? 2C2H2 plus 5O2 gives 4CO2 plus 2H2O. Whatever numbers you can see in front of molecules are the number of molecules. So 2 molecules of acetylene combines with 5 molecules of oxygen to give 4 molecules of carbon dioxide and 2 molecules of water. 2 molecules of acetylene reacts with 5 molecules of oxygen to give 4 molecules of carbon dioxide and 2 molecules of water. Now let's follow Gay-Lussac's law here. So what is the ratio then here? 2:5. If I have to write here the ratio, 2:5:4:2. Can I write 2? No, because water is liquid. And in Gay-Lussac's law, volume of liquid is considered to be 0. So the ratio is whole number ratio. We are not getting fraction. But if you write 5 by 2, it will be a fraction. So you have to remove that. Whatever you are getting in the denominator, you have to multiply that with the same number, then you will get whole number. Your intention is to get whole number. Okay? So this is the balanced equation now. Now what you can write here? 2 volume of acetylene reacts with 5 volumes of oxygen to give 4 volumes of carbon dioxide, and this is because this is water, liquid. So this is gas, this is also gas, and this is liquid. So liquid will have volume 0 in Galois X above, because it is applicable to gas only. Okay, so I think up to this it is okay. First of all, what you will be doing, you will be writing a chemical reaction. If chemical reaction is given, if chemical equation is given, then you have to balance the chemical equation by any ways, whatever ways you like. Okay, you have to balance the chemical equation, provided while balancing your chemical equation, you should not get any fraction. If you are getting the fraction, then also you have to reduce that fraction into a whole number. So on balancing the equation, whatever number comes in front of the molecule, that becomes number of molecules, and you can write 2 volume of acetylene, 5 is in front of oxygen, so 5 volume, 4 is in front of carbon dioxide, so 4 volumes. 4 volumes. That means 2 molecules combines with 5 molecules to give 4 molecules of carbon dioxide. Means if you are reacting 1 liter, okay, if you consider this volume as liter, then 2 liter of acetylene can react with 5 liter of oxygen to give 4 liter of carbon dioxide. I think it is understood. 2 liter of acetylene gas if you are taking, then you need 5 liters of oxygen gas to completely burn this acetylene. Then 4 liters of carbon dioxide will be formed as a result. Okay, so 2 volumes needs 5 volumes to give 4 volumes of carbon dioxide. Now what you can write? So now you will be following unitary method. Okay. So let me do this. Now, what is your question? What volume of oxygen would be required to burn completely 200 ml of acetylene? This is your first question. What volume of oxygen? That means we need to find the volume of oxygen required to burn 200 ml of acetylene. So, what do you do then? So, here one can get 2 volume of acetylene requires 5 volume of oxygen. Then right here, 2 volume of C2H2 requires 5 volume of oxygen. Got it? So from this what you will do? You will convert this into a word. So 2 volume of acetylene requires 5 volume of oxygen. Whatever you have to find. In mathematics, I think it is said, whatever you have to find, most probably, if you write this on this side, it will be easy for you. Known you will write this side, unknown you will write on the right side, known on the left side. So 2 volume of acetylene requires 5 volume of oxygen. Then, if we take 1 volume of C2H2 requires 5/2. If 2 volume requires 5 volume, then 1 volume requires less. 2 volume means 5 volume means 1 volume means 2.5, that is 5/2. So 5/2 volume of oxygen. Then what is the volume given? 200 ml. So you can write here 200 ml of C2H2 requires 5/2 into 200 ml of oxygen. That is equal to 2 and 200, 100. So that is equal to 5 into 100, 500 ml ml of oxygen. Okay. So 200 ml of acetylene requires 500 ml of oxygen to burn completely. To burn completely. Then what is our next question? What is our next question? What is our next question? Our next question is, what would be the volume of carbon dioxide formed? So what will the volume of carbon dioxide formed? So 2 volume is giving 4 volume. 2 volume of acetylene is giving 4 volume of carbon dioxide. Now you can take this 5 volume also, because 5 volume of oxygen is also now known. 500 ml is required. But it will be appropriate if you take the figure given in the question only. So you can take this or this, because this is also known now. One must be known, one is unknown. If both are unknown, you cannot find. So one has to be known. So let's take this. Then again 2 volume of C2H2 forms 4 volume of CO2. 2 volume of C2H2 forms 4 volume of CO2. Then 1 volume of C2H2 forms 4 by 2. If 2 volume forms 4 volume, then 1 volume forms less. So 4 by 2, that is 2 volume of carbon dioxide. Let's solve this question. Then what is the given volume of acetylene? 200 ml. So 200 ml of C2H2 forms 2 into 200 ml of carbon dioxide. That is 400 ml of carbon dioxide. So what volume of oxygen is required to completely burn 200 ml of C2H2? 500 ml of oxygen. And what volume of carbon dioxide is formed by burning 200 ml of acetylene? By burning 200 ml of acetylene, we are getting 400 ml of carbon dioxide. Now, Avogadros law. So, last class, what we did new is Gay-Lussac's law of combining volumes that we did along with the example. Now we'll be doing Avogadros law. So this also a statement and all I said last time only, last class. So but then also I am repeating it. Avogadros law states that equal volume of all gases at same conditions of temperature and pressure will have equal number of molecules. So what does it say? It says that equal volume of all gases, whatever gases it may be hydrogen gas, it may be carbon dioxide, ammonia gas, whatever gas it is. If equal volume is there, then they will have equal number of molecules. They will have equal number of molecules. So number of molecules, that means number of molecules in 1 liter of hydrogen and 1 liter of hydrogen and number of molecules in 1 liter of oxygen at similar conditions, at same conditions, will have equal number of molecules. So number of molecules in 1 liter of hydrogen is equal to same number of molecules in 1 liter of oxygen at same temperature and pressure. If the temperature and pressure at which the volume is measured is same, then equal volume of gas will have equal number of molecules. If 1 liter of hydrogen gas has 6.02 into 10 power 23 molecules, then 1 liter of oxygen also will have the same number of molecules provided the temperature and pressure is same. So, on the basis of this, on Avogadros law, we'll do numerical, that is example number 10, page number 74 of your book. So, if 50 cc of a gas A contains Y molecules, if 50 cc cubic centimeter or 50 ml, that also you can consider, because 1 cc is equal to 1 ml. 1 cc is equal to 1 ml. Okay, so 50 cc of a gas A contains Y molecules. How many molecules? 1 molecules. How many molecules of gas B will be present in 25 cc of B under same conditions? So condition same means equal volume will have equal number of molecules. Condition at which the volume of A and B is measured is same. That means equal volume will have equal number of molecules. So 50 cc is having Y molecules, 50 cc of A is having Y molecules, means 50 cc of B also will have Y molecules. So 50 cc, that means what we can write? What we can write? According to Avogadros law, according to Avogadros law, 50 cc of A will contain same number of molecules as 50 cc of B at same conditions. 50 cc of A will contain same number of molecules as 50 cc of B at same conditions. At same conditions. That means from here what we can write? 50 cc of B contain 50 cc of B contains how many molecules then? 50 cc of A contains Y molecules. That means 50 cc of B also contains Y molecules. 50 cc of A contains Y molecules, means 50 cc of B also contains Y molecules. So 50 cc of B contain Y molecules. Y molecules. Then 25 means half. That way also you can do, or if you want to go for unitary method, that also you can. That means 1 cc of B contain Y by 50 molecules. That means 25 cc of B contain Y by 50 into 25 molecules. So 25, 1, 25, 25 2s are 50. That means how much you are getting? That is Y by 2 molecules. That means exactly half. 50 cc has Y molecules, means 25 cc will have Y by 2 molecules. 50 cc have Y molecules, means 25 cc will have half of it. That means Y by 2 molecules. Then we'll be doing molecular mass. So this molecular mass we have been doing from class 8 itself, then also for slight revisions, for a short revision we will be doing. Relative molecular mass. Relative molecular mass. So, what is relative molecular mass? Mass of a molecule. Mass of a molecule is mass of a molecule is relative molecular mass. That means how many times a molecule is heavier than 1/12 part of carbon 12 atom is its relative molecular mass. So, we will be calculating relative molecular mass. Example 1, page number 77. Calculate the molecular mass of the following compounds. A. Copper sulfate crystal, that is what the molecular formula of copper sulfate crystal, CuSO4.5H2O. B. Ammonium sulfate. Ammonium sulfate. And what is the formula for ammonium sulfate? It is NH4 whole twice SO4. Given, what are the things given? Given molecular, this one, relative atomic mass. Atomic mass of copper is 63.5. Then atomic mass of sulfur is 32. Then atomic mass of nitrogen is 14. Atomic mass of oxygen is 16 and atomic mass of hydrogen is 1. This is given. Then we have to calculate molecular mass of the following compounds. Now, how to find molecular mass of copper sulfate crystal? So you can write here molecular mass of CuSO4.5H2O is equal to copper. What is molecular mass actually? It is sum of the mass of atoms in a molecule. Sum of the mass of atoms in a molecule. So, what are the atoms in this molecule? Copper. 1 atom copper, 1 atom sulfur, 4 atoms of oxygen here, then 5 molecules of water. What are the things here? 1 copper atom, 1 sulfur atom, 4 copper sulfate crystal. 1 molecule of copper sulfate crystal comprises of 1 atom of copper, 1 atom of sulfur, 4 atoms of oxygen and 5 molecules of water. It is water of crystallized hydrated solid. Okay, then how to do? 1 atom of copper. So, what is the atomic mass of copper? 63.5. That means you can write 1 atom of copper. Number of atoms into atomic mass 63.5 plus 1 atom of sulfur. 1 into, what is the atomic mass of sulfur? 32. 32 plus 4 atoms of oxygen. So 4 into oxygen 16 plus 5 molecules of water. So in water, how many hydrogen atoms? 2. What is the atomic mass of hydrogen? 1. Plus what is the number of atoms of oxygen is 1. And what is the mass of oxygen atom? 16. This is the thing. Now 63.5 plus 1 into 32. 32 plus 4 into 16. 64 plus 5 in bracket 2 plus 16, 18. Then you will be getting 63.5 plus 32 plus 64 plus 90. Now add all 0.5, then 0, 4 plus 2, 6, 6 and 3, 9. Then 9, 6, 15 and 3, 18 and 6, 18 and 6, 24. 24. So AMU, atomic mass unit. That means what is the molecular mass of copper sulfate crystal? It is 249.5 AMU. This we need when we will be doing percentage composition. That's why it is very much important. Okay, so 249.5 AMU we got. Now we'll be calculating molecular mass of ammonium sulfate. We'll be calculating molecular mass of ammonium sulfate. Molecular mass of ammonium sulfate. What is the formula? NH4 whole twice SO4. Now, what are the atoms present in this molecule? 2 atoms of, this 2 is for all, 2 atoms of nitrogen, 1 atom of sulfur, 4 atoms of oxygen and 8 atoms of hydrogen. Got it? 2 atoms of nitrogen and 8 atoms, 4 2s are 8. 8 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. So this many atoms are there in a molecule of ammonium sulfate. So sum of all the atomic masses of atoms present in a molecule becomes is relative molecular mass. So let's write 2 into nitrogen. 2 into nitrogen. So nitrogen, what is the atomic mass of nitrogen? 14. Plus 8 into hydrogen, 1. Plus sulfur, 1 into 32. Plus 4 into 16. So you are getting 28 plus 8 plus 32 plus 64. Then go on adding. 4 plus 2, 6 plus 8. 14 plus 8, 22. 14 plus 8, 22. Then 2 left. 6, 8, 11 and 2, 13. 11 and 2, 13. 132. How much? 132. And last you write atomic mass unit. So this is molecular mass of ammonium sulfate, and you can try finding, calculating molecular mass of other molecules also. That will give you confidence. That will give you more confidence. Then more. What is the mole? Last class I was telling you mole. What is a mole? Mole concept, actually the concept of mole is similar to that of the concept of dozen. 1 dozen of anything means 12. 1 dozen of anything means 12. Then 1 mole means 6.02 into 10 to the power 23. So 1 mole. A mole is a collection of 6 into 10 to the power 23 particles. These particles may be atoms, may be molecules, may be ions, anything. But a mole is a collection of 6 into 10 to the power 23 particles. A mole is a collection of 6 into 10 to the power 23 particles. Then 1 mole of any gaseous substance occupies volume of 22.4 decimeter cube or 22.4 liter or 22400 centimeter cube or 22400 ml. So 1 mole of any gaseous substance, or gaseous molecule occupies 22.4 decimeter cube or 22.4 liter or 22,400 centimeter cube or 22,400 ml volume. And this volume of a gas occupied by 1 mole of it is called molar volume.